Here, we will learn about databases. We'll start by understanding what a database is and explore its purpose and benefits. Then we'll differentiate between relational and non-relational databases, and finally, we'll take a look at how they are used in various roles. Let's imagine we are data professionals, and an organization approaches us for help. They manage a large-scale tetanus vaccination campaign in Zambia and need an efficient database to organize their data. Let's explore how databases can help them achieve their goals. A database is like a digital library, where data are organized and stored in a way that allows for easy access and management. The campaign needs a database to store, retrieve, and manage large amounts of information about their patients, vaccine doses, and the clinics where the vaccine doses are administered to patients. Databases can be broadly categorized into two types: relational databases, often referred to as SQL databases, and non-relational databases, known as NoSQL databases. Relational databases store data in tables with rows and columns, much like a spreadsheet, but much more complex. Each table stores data about a specific type of object, such as patients, vaccine doses, clinics, and so on. These tables are linked through relationships, which is why they're called relational databases. Structured query language, or SQL, is the language that we use to interact with these databases, using keywords to construct and manipulate databases. Examples of relational databases include MySQL, PostgreSQL, and Oracle. They excel at handling structured data and complex queries, making them suitable for organizations with well-defined data models and relationships. Non-relational databases, on the other hand, don't have tables or relationships, and they generally do not use or support SQL. Instead, they have their own query languages. Data in non-relational databases are stored in various formats, such as key-value pairs, documents, or graphs. They are more flexible than relational databases and, as such, are often used in scenarios where data constantly evolve or scale rapidly, such as social media platforms or real-time analytics. Examples of non-relational databases include MongoDB, Cassandra, and Redis. A relational database for the tetanus vaccine campaign is a good choice since the information is structured and related. For example, patients, vaccine doses, and clinics are all related because a patient receives a vaccine dosage at a clinic. To build any type of database, be it relational or non-relational, we need to consider the 5 key components of a database. These are hardware, software, data, procedures, and database access language. Hardware refers to the physical devices and equipment used to store and process the data, such as servers, storage devices, and network components. Software is a tool used to manage and interact with a database, such as the database management system. Data represent the actual information stored in the database, which is the core of any database system. Data can be, for example, patient records, vaccine inventory, and distribution data. Procedures are the rules and guidelines for using, maintaining, and accessing the database, such as data validation and user access controls. A database access language is the language used to interact with the database. For example, SQL, which allows us to perform operations like inserting, updating, deleting, and retrieving data. Each of these components play a crucial role in the overall functioning of the database. Now, you might ask, why can't we just use a spreadsheet? The short answer is that databases far surpass the abilities of spreadsheets. While spreadsheets are useful for certain tasks, such as small-scale data management, databases offer several advantages that make them more suitable for many more cases. In the past, our example campaign would have relied on spreadsheets to track vaccine distribution, monitor doses administered, and record patient information. However, as the campaign gained momentum, the shortcomings of spreadsheets became evident. Due to the sheer volume of data, multiple versions of the spreadsheet were created, which led to confusion and inconsistencies. As such, critical vaccination data are at risk of being lost or misinterpreted. More so, the lack of data validation in a spreadsheet means that crucial details such as patient demographics and vaccination schedules were prone to human error. This creates challenges in identifying high-risk areas and effectively managing the vaccination rollout. What the campaign needs is a more robust data management solution, and this is where databases come in. We can implement database systems specifically designed for healthcare management. A database allows for centralized and secure storage of vaccination data, streamlined reporting, and automated data validation to accuracy, efficiency, and decision-making due to its ability to handle complex operations and intricate relationships between data points. This makes it easier to identify tetanus vaccination trends, allocate resources effectively, and ensure that priority groups receive the necessary doses. The database also enables seamless collaboration with healthcare providers and timely reporting to stakeholders. Furthermore, databases excel in handling large volumes of data and can accommodate growing data needs, making them a versatile solution for the campaign as it grows over time. Nowadays, most organizations can't survive without databases, so it is crucial that we understand how to use them. Throughout the campaign, the database will serve as a resource for several people. Let's explore 3 main roles who will use the database to manage and analyze data. First, we have the database administrators, or DBAs. These individuals focus on managing and maintaining the databases, ensuring their smooth operation, performance, security, and data integrity. Next, we have software developers. They are the masterminds behind the applications that interact with databases. They integrate databases into their software, write efficient queries, and ensure smooth data operations for the end users. Lastly, we have the end users. Multiple roles fall into this category, such as data engineers, analysts, and scientists. They use the database to perform a range of different tasks, including managing the data, generating reports, and making predictions to drive decision-making.